MS Ramaya University of Applied Sciences.
Hi students, today we learn about limit test for arsenic. Aim to carry out the limit test for arsenic and to determine whether the sample is suitable for pharmaceutical use or not. The sources of arsenic impurities in the pharmaceutical may be due to the use of tap water or use of chemicals made of natural source or use of metallic containers for preparing pharmaceuticals. Experimental setup. Under this, the apparatus required are a pair of arsenic apparatus, beaker, measuring cylinder, glass rods, burette with stand, funnels, and tickle balance. Chemicals and reagents required are potassium iodide, stannous chloride, zinc granules, distilled water, arsenic standard solution, mercury chloride paper, lead acetate cotton wool, and sample. Principle. It is based on converting any arsenic impurities if present in the sample to arsine gas by a series of reactions. The arsine gas is made to come in contact with mercury chloride test paper, whereby it produces a yellow or brown stain due to the formation of mercuric arsenate, depending upon the amount of impurity present in the given sample, and then compared with arsenic standard containing 10 parts per million of arsenic ions, prepared by arsenic trioxide. The stain produced by the sample solution on the mercury chloride paper is compared with a standard stain. If the color stain produced in the sample is less than the standard, it passes the limit test for arsenic. If the color stain produced in the sample is more than the standard, the sample fails the limit test for arsenic when compared in direct sunlight. The chemical reaction involved in this limit test is as follows. First, the trivalent state and the pentavalent state of the arsenic impurities, if present, are converted to their respective acids by treating with hydrochloric acid. Further, the pentavalent state of arsenic is converted to trivalent state by using stannous chloride and potassium iodide. Next, the zinc granules are made to react with hydrochloric acid to produce the nascent hydrogen. Further, this nascent hydrogen reacts with the trivalent state of arsenic acid to form arsine gas. This arsine gas then reacts with the mercury chloride paper to form mercuric arsenate. If any impurities like hydrogen sulfide is present in the solution, then it is trapped by using lead acetate cotton wool roll of reagents. Hydrochloric acid converts arsenic if present to their respective arsenic acid. Potassium iodide and stannous chloride are used as reducing agent for converting arsenous acid to arsenic acid. Zinc granules. The reaction between zinc granules and hydrochloric acid results in the formation of hydrogen gas. Lead acetate cotton wool. Metallic zinc may contain traces of sulfide as impurity, which on reaction with acid yields hydrogen sulfide. The lead acetate cotton wool is used to trap any hydrogen sulfide evolved together with arsine gas. The hydrogen sulfide may react with the mercury chloride paper and developing a dark stain, thus interfering with the formation of the required mercuric arsenate stain. Arsenic standard solution used for comparing with sample. Mercury chloride paper used for identifying the arsenic impurity if present in the sample. To carry out this limit test, we use a special type of apparatus which is designed by Williams-Monnier, and the name of the apparatus is electrolytic apparatus. The slide gives the description of this apparatus. Experimental procedure. To prepare the standard stain and the sample stain. To prepare the sample stain, dissolve 10 grams of sodium chloride or the sample as per the pharmacopoeial standard into 50 ml of water. The resulting solution will compile with limit test for arsenic of 1 ppm. Add 10 ml of stannous chloride solution. Add 1 gram of potassium iodide and 10 grams of zinc granules. Immediately assemble the apparatus. Allow it to stand for 45 minutes at 45 degrees centigrade. After 40 minutes, if any stain is produced on the mercury chloride paper, is compared with the standard stain. The standard stain is prepared similarly by taking 1 ml of arsenic standard solution and diluting it to 50 ml with water, then treating with 10 ml of stannous chloride solution, 1 gram of potassium iodide, 10 grams of zinc granules. Immediately assemble the apparatus. Allow it to stand for 40 minutes at 45 degrees centigrade. After 40 minutes, any stain produced on the mercury chloride paper is compared. Result or conclusion: if the color stain produced in the sample is less than the standard, it passes the limit test for arsenic. If the color stain produced in the sample is more than the standard, the sample fails the limit test when compared in direct sunlight. The slide shows how to compare and give the results if the samples are passing sample or a failing sample.
Hi students, the title of the experiment is Limit Test for Arsenic. Aim of the experiment is to carry out the limit test for arsenic and to determine whether the sample is suitable for the pharmacopoeial use or not. The chemicals required for this experiment are standard arsenic solution, which is used for comparing with the sample solution to check whether it contains the arsenic impurity or not. It is prepared by taking arsenic trioxide, which contains 10 parts per million of arsenic in it. Stannated hydrochloride, it acts as a reducing agent. It converts the pentavalent state of arsenic to the trivalent state of arsenic if present in the sample solution. Potassium iodide acts as a reducing agent. Zinc granules are used to produce the nascent hydrogen, which is essential for converting the arsenic acid to arsine gas. Lead acetate cotton wool, which is used to trap the hydrogen sulfide gas if present as an impurity in the solution. Mercury chloride paper, it acts as a reagent for identifying the arsenic if present in the sample solution. Sample solution, in which we are going to check whether the arsenic is present or absent, and distilled water. The apparatus required for this experiment are a pair of arsenic apparatus, one for the standard and one for the sample. Butter paper, spatula, labels, burettes with burette stand, funnels for filling the respective reagents, and an analytical balance. Now we'll start the experiment. First step, we'll fill the burette, we'll fill with standard arsenic solution. Adjust to 0. With lower meniscus. Now in the second burette, we will fill stannated hydrochloric acid. After filling the burettes with the respective reagents, now we will assemble the arsenic apparatus. Label one apparatus as standard and another apparatus as sample. Next, we will weigh potassium iodide for the experiment, 1 gram for the standard solution and 1 gram for sample solution. One gram of potassium iodide. For standard, similarly, we'll weigh 1 gram of potassium iodide for sample also. One gram of potassium iodide for preparing the sample solution. Now we'll weigh 10 grams of zinc granules. Approximately 10 grams of zinc granules. Similarly, weigh one more 10 grams of zinc granules for the sample solution. Now we will assemble the apparatus. First, we have to insert the lead acetate cotton wool in the capillary tube. Take a small bit of lead acetate cotton wool, pack it loosely this way in the capillary tube. Then keep mercury chloride paper on the lower bunk of the capillary tube. Keep the upper bunk on the capillary tube and arrange it in this way. Similarly, prepare for the sample also. Take the lead acetate cotton wool, pack it loosely After arranging the capillary tubes, next in the standard apparatus, take 1 ml of standard arsenic solution which contains 10 parts per million of arsenic. Then add 50 ml of distilled water. Next, in the sample apparatus, we will take 50 ml of sample solution. Now, to standard as well as to the sample solution, we will add 10 ml of stannated hydrochloride. After adding stannated hydrochloride, now we will add 1 gram of potassium iodide into the standard apparatus and 1 gram of potassium iodide into the sample apparatus and dissolve it. Now we will add 10 grams of zinc granules into the standard apparatus and stopper it immediately. Similarly, we will add 10 grams of zinc granules into sample apparatus, stopper it immediately with the capillary tube. After arranging the apparatus, allow the reaction to take place for 45 minutes. You can see the evolution of hydrogen gas taking place, which is essential for converting the arsenic, if present, to an arsine gas, which passes through the capillary tube and stains the mercury chloride paper. The mercury chloride paper is compared for the stain in direct sunlight. After 45 minutes, check the mercury chloride paper for the stain. Now, how to report whether the given sample passes the limit test for arsenic or not? We will compare the standard stain with the sample stain. The standard stain is more intense compared to the sample stain. Hence, the given sample passes the limit test for arsenic. This completes the limit test for arsenic.
At MSR UAS, we spark your imagination unlike any other.